Okay, if you're watching this video, you've already completed the ones, or at least you understand the previous ones where we talk about decision symbols, processing symbols, data symbols, flow symbols, and you understand decisions with multiple outcomes. What I want to do next is talk to you about loops. So let's create a new document. New. Flowchart, BPMN 2.0. Let's model, how about the McDonald's drive-thru? Or any drive-thru, it doesn't matter. What I want though is to model the process of calculating a running total when you don't know how many items are going to be purchased. So someone gives you one item. You display the item with the tax and total shown below, and then you ask the question, do you want something else with that? Or do you want something more? And so they have to answer yes or no, and then you add the next item and you keep going until they say no. Alright, so let's begin with a start symbol. Oh, as usual, let me now here I forgot to output results, showing this last one is happening right down here. Processing is happening all along here. What I want to do is make sure I don't forget these things. Control C, and our example right here. Okay, start. Let's shrink this down a little bit. Okay, we need to collect the inputs from users. So for the first item, they show up. We need one of these rhombus objects here. Input. We better go ahead and grab some inputs from setup. Like we're going to need a tax rate. Whoops. I got to, let's fix this first of all. Okay, move that down there. Inputs from setup, it's shift enter. We're going to need tax rate. I think that's all we're going to need right for now from setup. Let's go ahead and get our legend going. Legend. Let's go and align this part left. TR equals tax rate, which equals 0.0625 for now. Okay. Let's collect the next input from the user. We're going to input. Let's do item and quantity. So we'll say I and Q. Let's add those. I equals item, Q equals quantity. Okay, let's add some connectors. Start, input, input, input. Let's shrink this down a ways to just what we need to fit here in the screen. Okay. So they've given us an input. Let's calculate a total. That's not so hard. We're going to grab a processing box. We're going to need something for balance. B equals balance. And B, whoops, B is going to equal tax rate times item times quantity. Okay. Pretty straightforward, nothing too complicated there. Draw our connector. Okay, we want to output this result back to the customer. So let's grab a data box, and we're going to display this, not print on paper, not prompt with a pop-up box. We're going to display on the computerized screen outside the drive-thru. So here we go, and we're going to display balance. Whoops. Balance, and I'm going to say this is an input from setup. This is an output from that was collected from the user. So I put it in parentheses like that. So I display this. Now my perfect categorization here of collect inputs, perform processing and outputs in this order is about to go away, because now that I've displayed this, I need to ask them a question and repeat the process. So let me show you what I mean here. We've displayed the balance of the very first item they've ordered. The next thing we need to do is output a question to them. So let's output, if this is a computer speaking, which some of the drive-thrus have now, we're going to need another one of these, and we're going to display, yeah, I'll make this a separate box. Display, would you like anything else? Okay, no problem. Let's make this smaller. Let's connect it. Here we go. Next, we need to collect an input from them. We need to collect their response. So again, this could them just be verbally speaking their response, but the computer is going to have to either listen to it and decide if it's a yes or a no, or if the person on the other end of the line, they're going to have to enter into the computer, yes, another item's coming. So we need an input box to gather R for the response. So let's put this up here. R equals response. Alright, let's make this smaller. There it is. Let's connect it. Okay, now that we have the response, what do we do next? Well, we have to make a decision. So let's grab a decision symbol. We have to decide, does R equal yes? If R equals yes, they would like something else, we're going to have to go all the way back and start over and collect inputs, reprocess a balance, display the balance, and then ask them again, would you like anything else? If not, then we're simply going to end the process. So let's make this only as big as we need it to be. Let's connect things. We grab the input R, and then we ask a question, does R equal yes? If let's first handle the no condition, how about? Because that'll be a bit simpler. Let me move this over. If no, the balance has already been calculated right here. So if they answer no, all we want to do is output the results, right? Or output the balance. Or output please pull forward or something like that. So let's do that. Let's say we're going to display, oh, come on. Enter, pull forward, because the balance has already been calculated and displayed to them. They know what it's going to be. Or what we can need to do at this point, maybe better, is both display this and print their receipt out. So let's make this a bit bigger. Please pull forward. Got it. And then from there, let's add one more where we print the balance, the item, the quantity, and that's probably good. However, there's potentially going to be many items and quantities that we're going to collect. So I'll come back to how we'll handle that in just a minute. But let's go ahead and end this process after that receipt's printed. There we go. Change this to end. Got it. Let's connect the dots. So although that says yes, this should be the no condition, so I'll change that to no. Move that over a bit. Move all of these over a bit. Alright, connect, and it's done. Let me move these a little further down. Okay, now let's handle the yes condition. If yes, well, we need to go and do everything all over again. Do we need to recalculate the balance? If yes, yes. We need to collect the inputs, yes. So what we're trying to do basically is draw a circle around everything that needs to be repeated every time they want to add another item. And we don't want to include the things that don't need to be repeated. For example, this inputs from setup TR right here. Once we grab the tax rate once, we don't need to keep getting it every time they want to add another order. It only needs to be collected one time. So what I want to do instead is draw a line that's going to loop back no or yes off of here and come back up and start this process again. Well, the problem with that is, remember, I still have this, well, I deleted it a little prematurely. If I do this and say go back to input item and quantity again, I violated one of my rules. Remember, one of the rules is I can only have 2 arrows into an input or a data symbol and 1 coming out. So what do I do to solve this problem? Well, that's what that connector symbol is for. Let's bring this back in. I don't need the letter A, delete. Let's make this a whole lot smaller. Let's put it right here. And instead of connecting there, we're going to connect right here. Let's add these flow lines back in. I think I might have to zoom in here. There we go. Okay. So, let me expand that a bit. Oh, not that much. There we go. All right. So we get to this point. Would you like anything else? They input their response. Does the response equal yes? Oh, this, I need to change that to say yes. If it equals yes, go back here to connector symbol, which goes and flows here to the input. And we once again grab I for an item and Q for a quantity. We recalculate the balance. We display the balance. Then we ask them, would you like anything else? They input no this time. So instead of following the yes, we go to no. We display please pull forward. We also output and print their receipt, and the process ends. Well, look here at the receipt. They've gone through this process twice. So I just represent, which item does this represent? Because we have multiple items. I can't sit here and put IQ multiple times because I don't know how many times this loop is going to end. So all I'm going to do here is say I sub n, Q sub n, and I'll have to find some way to make that text smaller so it makes sense. It should be subscript. Can I do that here? I probably can, but I'm not going to worry about it. Basically, in other words, we print the total balance and each I and corresponding Q, and that's all that means. So loops aren't that bad. However, I do want to make this one a little bit more complicated. I want to teach you how to have a sort of a kill switch for a loop so we never get into a never-ending loop. Let's say that one of Google's self-driving cars pulls into your drive-thru, and when the drive-thru computer says, would you like anything else, Google's self-driving car doesn't realize it has a limit and wants to buy everything infinitely, and it always says yes and orders another item, and it never ends. Okay, so we're stuck in some infinite loop. Let's find a way, or let's make some decision that when people go through our drive-thru, there's going to be a limit of 50 items or something like that. So what we need to do is when we loop, before we go back into the input again, we need to check and see if the kill switch needs to be activated. So let me back this off a bit, and before we do that, I want to calculate exactly how many items have been ordered. Do we want to do this separate items on a receipt or items times quantity? You know, I don't know. Let's decide that this is total items. It can't have more than 50. So let's put in a processing box here. And in this processing box, we're going to have a T, which is going to equal total items. So let's put this up here. T equals total number of items. T is going to equal the sum of item times quantity for all items, and that's good enough to represent that right there. So T is calculated. Let me spread that out. There we go. Whoops, cancel. Stay on this page. I didn't mean to do that. All right, so next, after we've calculated the total number of items, we need a decision symbol. Is this greater or less than 50? All right, so this is going to say total greater than or equal to 50. Let's make this only as big as we need it. Okay, let's add a connector. Okay, let's say no, it's not. So come here and we'll go back in our connector like we did before. It's not greater than 50, so continue looping. However, let's say it is greater than 50. Let's add another connector that comes off here that will represent yes. Whoops, come on. Yes. And then we should probably display something like you've reached your limit and then print the bill or tell them to please pull forward. So let's do that. Let's pull in here an output and say display, you have reached your drive through limit. There we go. Then remember, I can't connect this directly into display please pull forward because I can only have one flow symbol going into a data box. So I'm going to need, let me give myself a bit more room here. Whoops, come on. Down, there we go. So I'm going to need a connector. Let me change this or pull this off of there. Add in a connector. Delete that A. Make this a bit smaller. There we go. Now no can flow right into here. This one can flow from here to here. And this one can flow from here to here. Okay, that does it. So I come in, I input an item and a quantity, I get my balance, it's displayed back to me. They display back, would you like anything else? I input a response, I say yes. So I go down to here, I total my sum. My total items is, I just ordered a drink so far, one drink. So my total is 1. Total is not greater than 50, so it goes back into my loop, and this continues until eventually I've reached 50, and it gets to this point now that total is greater than or equal to 50. Yes, it goes here and it says you've reached your drive-through limit, and we're going to simply force them and show a message that says please pull forward. Then we print their bill and it ends. So here's an example of both a loop and a loop counter, so to speak, which will kill the loop and make sure that it never ends up as an infinite loop. See your reading here on My Educator for more examples of loops and kill switches.